The license managers. License managers can bring you a lot of problems or can be your best friends. It depends on how you work with them. So first of all, I would like to introduce us what we do. We work at Kaspersky Lab ICS CERT team. This is Industrial Control System Cyber Emergency Response team. We do the different penetration testing, vulnerability research, also the protection, different things for our customers and for the whole world. We do different CTFs, we create CTFs. So today, our annual Kaspersky Industrial CTF starts. So you're more than welcome to participate in that type of competition. So you see the link, it's https ctf.kaspersky.com. So we have really cool tasks, and the finals, those are qualifications, and the finals will take place in Singapore next year. We have created a couple of years ago automatic bartenders, so we are Alcabot, we call them Alcabot, we are Godfathers, and we also do different other cool stuff. So, license managers. As far as you know, there are different ways to do the licensing for different types of the software. So, as you remember, for example, in Windows operating system, like in XP, you need to provide the string that makes your version of Windows operation system valid, like licensed. Sometimes you need to provide the token. So I have here like this token, like these tokens. So if you have software installed, you need to plug in the USB token, and then software understands that the valid version of token is being installed, and everything works perfectly. So basically all these license managers, they are anti-piracy thing. They can be software or hardware guys. Sometimes they're self-made for one company by the same company, so we will be bringing some examples of that. And in most of the cases, they're being used as the third-party code in like a bigger system. So for example, if you install, I don't know, some sort of software, the license management driver is being installed automatically. Unfortunately, some of the vendors that are using that type of installation, they do not check any security of those license managers. And there is a blind trust issue, so they basically trust that code that being in the package of their main software installation package. And so today we would like to start with the first example. It's Siemens automated license managers. So we will be bringing only the statistics for this license management. So this is the example of the company who created their license manager only for their internal purposes. So, for example, if you know about the industrial control systems, especially the Siemens automation software, you can see that usually, like in 90% of the cases, the Siemens automated license manager is being installed with the whole package. This license manager was studied by different researchers for the last, I guess, what is it, 7-8 years. And the thing is that basically 50% of those discovered vulnerabilities belong to our team. So we started research in 2016, and usually like once or twice a year we try again to find the vulnerabilities in Siemens automated license manager, and we usually have success in that. So as you can see, there are different types of the vulnerabilities being discovered in the binary file. So not only typical binary vulnerabilities that allow you to do the remote code execution, but also different injections like path traversals and all those kind of things. So sometimes it can bring you a lot of problem. The second case is our research started 2 years ago. 2 years ago, yes, or 2 or 1.5 years ago. This is a Gemalto. It's a huge company, and they also do the license management business. They work in a business-to-business thing. So basically they provide the OEM software. And so the first results showed us that, well, everything was really bad. So in a couple of minutes, Sergey will talk about technical details, talk about how they, for some reason, removed all the internal protections. So, and we realized that this type of license manager is being used super widely, like by huge companies like IBM, HP. They use that type of license management for the internal software and everything, and it being used by like banks, industrial control systems, telecommunication software, all the big players. We have seen, so we did different penetration tests for our customers, and in different locations, in different types of the companies, supported by different types of the software and hardware, we noticed one really strange binary file. It's hasp.lms.exe. So first we thought that it's some, I don't know, some strange thing, but then we started studying and we realized that this is basically a binary file for the license management. This is the software and hardware thing. So basically, you need to use this token and the software part. So this is the graphical example how those license management tokens looks like. You might see them in different types of the business, or you even might use it already. And now Sergey will explain more details on what is it made for and what types of the things are being inside of the binary files and everything.
Hello everybody. In addition, you should know the Gemalto as a SafeNet or Aladdin, because Gemalto bought SafeNet. SafeNet is like sounds more popular. This is hardware and software solution. Hardware part is token, Vladimir showed you, and the software part contains drivers, services, web application, a lot of binaries. I show you how you can install it. So there are three ways. First way, you plug in the token into the Windows PC with Windows system. Windows identify the token and token ID and try to search in Windows updates and download the software driver. Also with driver, service is installed. Service opens port 1947. The second way to install this application is manually download from the site Gemalto or SafeNet is available. That will be done the same way as the first case, except that also port number 1947 will be added to the exception of firewall. But in this case, you will be notified. I'll show you about the adding, open the port. And the third case is like hidden installation. If you buy some software, for example, SCADA or something, and during the installation, this software will be also installed, and the port also will be opened, but nobody tells you that the port is open and everyone can connect it to it. Okay, and this is the WinDBG screen. We found this is screen of one crash, and one main feature of this process, hasp.exe, is there is no software protection, no ISLR, no stack canaries, no so it's easy to exploit. And if you can see, this is small. Okay. The exception is application. The exception is application try to execute code at address AAAA. It's our payload. It's too hard to see nowadays because nowadays there are a lot of protection to start doing this way. And we was wondering why they remove all protection. We don't know. So if in this case it's easily to exploit, simple write rope chain, pop-red also known, and I will show how this exploit works. And
so in the quick statistics before the live demo, this is just a short number of the vulnerabilities identified in Gemalto and license management. So there were different types of the remote code executions with the really high privileges. We have identified a really strange behavior when the remote attacker could capture the NTLM hash of the user under which privileges the binary is being run. And so every time the binary is being run under the system privileges. So we managed to capture the system NTLM hash, and when we reported it to the vendor, they said like, so what? We said like, okay, you might do the like hash bypass attack or something like that, and they said like, no, that's a system user, it's just impossible to do. So we consider it as the vulnerability and really strange behavior. And also we have identified another strange behavior that allows you to do the remote configuration with the remote manipulations with the configuration file. So basically you can remotely insert your own what is it, the proxy server for the updates. And in terms of the so basically you can insert malicious proxy server and insert the malicious binaries for the updates. So, and right now we will be showing the remote code execution demo. Okay, so we're starting the attacker's machine and the victim's machine.
So we have two machines. It's like Windows. It's totally updated, so no vulnerability in Windows. And so two machines. First machine, this IP address is attacker. The second machine is victim. And between them, it's internal network. First of all, at the victim, as I told you, it's possible to download the application. This is a vulnerable one application. Now it's already fixed, and we will install. You can see that SafeNet incorporation because Gemalto also installation. Next. For lazy. Okay. It should be on. Okay, you can see that there is a notification that port number 1947 is opened. Okay, finish. Also, it was added in the firewall exceptions. Okay, security, Windows firewall. It's everything turned on. Mount. Okay, this. It's allowed to accept any connection. So it's now let's try to this application opens port 1947 and use either binary or HTTP protocol. It depends on the first 4 bytes. Let's try to connect to the victim machine using Internet Explorer. You can see this is small notification. It's forbidden. So it opened, but it's forbidden. We can, by default, have connection only locally. But there is one IP which can switch off this feature remotely without any authorization. I will show. This is script number 1. Okay. With success, refresh. That's it. This is feature. It's not vulnerability, as our as vendor told us. We don't know why. You can see admin control, but this is custom web application. It's not an Apache or something. It's custom, and it's possible. There's something like. There is like update form, and we find one field was vulnerable in this form, and we create an exploit. It's easy to create, as I told you. There is no protection. It's mainly possible to create rope chain like in beginning of 19th, and let's try to attack. First of all, we should use NCAT that we send the exploit to the victim, and when it works, it will make reverse connection to our PC. This is port number 4444. Okay, access. So we're listening. Script number 2. We send the exploit to the victim. Okay, you can see this is the netcat received connection, and using ipconfig. Okay, we at the victim computer. You can see the address, and moreover, who am I? Who am I? System. So we can do everything with the remote computer now. That's it.
Okay, so quick results. Okay, so yeah, quick results. So after we have reported all the vulnerability, Gemalto company made a really huge step in terms of the internal and external security. So they basically started working much better with the external security reports. They fixed all the vulnerabilities in a very short period of time, and we have identified that there is the response time for vulnerability reports was way shorter than before. So the next example, the third example, is Flexnet License Manager. This is a very new research that we have finished just, I don't know, 3 weeks ago, something like this. And what is it? This is this license manager is made by Flexera company. They are also a security player. I mean, they have some kind of security services and I guess software, something like this. So their license manager works as the business-to-business thing. So they provide a third-party code in like other installation packages, and we noticed that some of the industrial control systems, for example, in default installation package have two license managers, the Gemalto, the previous one, and this one, the Flexnet. So they work at the industrial control system field, double installation rate, and they have a very interesting feature that we will be talking about, is the customization for the vendors. So they can provide the default license manager, or they can do some different customization that can lead to huge security problems. So some quick explanation of what is it for. So they we studied only software part of this type of the license manager. It has the TCP port open to 7000, and we have found some interesting information about how the binary was compiled. And the thing is that most of the internal security mechanisms are turned on, and this is really good. So right now Sergey will explain basically the research details, how we started this research, how we studied the checksums and everything.
So first of all, we collected all traffic to the port 27000, and it's not compressed. With various the plain text could be grabbed, and we decide why. So let's do the stupid fuzzer, dummy fuzzer, and to like maybe we find something, and yes. I mentioned there is also one feature of this application. It works like a legal botnet. So if you install Flexnet application, it will try to find their neighbors to connect and collect some information about, I don't know, license maybe. I didn't figure out. And so its behavior looks like a botnet. About the binary, this is one binary who opens the port. It's lm.grd.exe. I will show you later. There is interesting hard-coded string. Developers didn't remove any meta information. We can see how it was built, where it was built, and some strange hardcode hidden folders, Flexnet in the C folder. So we will find after our research we found like 5 vulnerabilities. And the one logical privilege escalation of customization of one vendor. I will show you live demo how to exploit it. It's very easy. About Flexnet, more deeper. So as I told you, there is lm.grdl.exe process. It opens TCP port 27000. It uses custom protocol. We discovered that in this protocol there is checksums, 2 checksums. I have never seen it before. I will show how it works. How we discovered it. It's quite easy to reverse because there is no code protection, and it's easier to use a reverse tool like IDA Pro to reverse and to see how it works inside. About the custom protocol, there is the first byte, like a magic byte. There is two cases. Magic byte and a special case if magic byte 2F in hex. The first case very simple. The second byte of the protocol is a checksum. Checksum is for the control of the stability, and it plays. We can, if we want to fuzz the application, we can't send like a trash data. We should fix this field cover a lot of cases in the binary. So this checksum calculated very simple. It's a sum of all bytes in the package, except the itself. The second case, the first byte is 2F. The checksum is first 20 bytes, sum of 20 bytes of the packet. The second checksum, I will show you later how it works. It looks like a CRC 16, and length and method. Method. So if we want to call some action, we should point the method. I will show you later, and the data to the attached method. We have no idea about the methods. Yes, I will show how to collect it. About the, I told you about the first checksum. Sum of all. The first case, it's sum of all bytes of the packet. The second case is sum of 20 bytes, 1 and 4 in hex. Checksum, you can see the part of code, and there is a very it's like a CRC 16 modification, but table is calculated very funny. You can see the Easter egg. There is constant. If you print it down, for example, this one, 3A5B, it's like a smile. It's I don't know why a developer put it. It's like for fun, I think. So we decided to do stupid visor. It's we will send the trash some random data to the port 2700 and see the reaction of application and fix the checksum, both of them. We know the algorithm, so we modify the data, fix the sum, and send to the application. Application also has a log file, and it show if we see the locally the log file, there will be a lot of strings, like you can see lamp borrow 2, and there is in the quotes the number. Its number is like our method. So we discovered the name of the method. So maybe some special methods. And our visor was work, and one case was very interesting. The application was shut down. That's it, without an exception, by design. And moreover, it posts the line in the log file. It's LM shutdown. So there is a command. Without authorization, we can shut down the process. Okay, yes, it's logical DOS by design. The vendor told us this is a feature. We tried, so stupid visor is like okay, but it's not enough. We tried to use WinFL. FL visor is American visor loop. Win is like fit to the Windows. I patch all functions, socket, receive, send. It was working for 1 day, and after that, profit. There is four vulnerabilities. Vladimir.
Okay, sorry, I was solving the CTF that is going on right now. Okay, so the FlexNet. Unfortunately, so yeah, we started searching this manager for the some customization, and we found one really huge vendor. That was really interesting to study. Unfortunately, right now we cannot disclose the vendor. We will be able to do it after December or something. As I mentioned before, they do the customization, and this type of the customization brought us a very interesting bug. So in the wild, you basically cannot see it very often. It's a logical local privilege escalation. So usually if you see the local privilege escalation, it's more like binary vulnerability, and well, there is always a risk to crash something during the binary vulnerability exploitation. And here we see the logical local privilege escalation that gives you straight system privileges. And also, if you take this customization, you will see all the same vulnerabilities that we found before, the logical shutdown, process shutdown and everything. So basically, in the customization, we see more bugs than, more vulnerabilities than in default installation. And we will be showing right now the live demo of local privilege escalation with one very interesting thing. So everyone, like all the developers of Windows operation system, they were lying to you, saying that there is no desktop for system user. During this exploitation, we will be showing the first time in the history the desktop of a built-in system user. Okay, so we have demo.
No? Okay. Yes. Okay. So this is the Windows. Our secret vendor application is already installed. We log in using limited permissions. It's standard user. It can't even create a folder at the. For example, if we try to create the folder in the Windows. No. It's, I think. Okay, it's possible, but there is. Okay, this is limited user. Yes, for sure. It's possible to create the files in the root folder and not files, folder. And the folder, it's possible to create a file, any file. So the process is launched. We're using the first logical DOS, as I told you. Okay, let's switch off. Okay, you can see information. It's like tools by design. It's installed with the Flexnet. Also, like you can use this like a user and send the shutdown command. Okay, yes. So it's shut down. And after that, it's possible to modify one license manager config file. Let's do it. You can see it, config file, it's some custom config file, but this field, one field, is very interesting. There is this string will be grabbed and added .NET exe and launched by the service when it starts. So it's limitation only 10 bytes. That's why we will create. We will do the next way. Create the folder Y and create the y.exe file. I will show you content, and we needn't to add the .exe because it will add it. Okay, let's save it. So first, we should create the, as I told you, well, it's possible to create folder Y and copy the. Okay, you can see the file. It's simple. It's create the service and started seeing the exe. That's it. It's file with user interaction type. We compiled it, and there is y.exe file. Okay, we copy to this folder. And also there is installed some service with one custom port. We can send the packet, and it will start again the service license manager. It's like a feature. That's also okay. Start service. And you can see the first of the history, the desktop of system user. Okay. Oh. View message. One sec. Okay, this is the desktop of system user. Who am I? System. So that's it.
Okay. Not this one. Use this one. Okay. So, right. So, in conclusion of this research, so the most of the fixes are gonna show up after December 20th this year. We can definitely say that these guys are using a security development lifecycle during the development process, and which is really good because well. There are some vulnerabilities that we have reported. One is the remote code execution. So, and we can say that it was pretty hard to execute the code. And based on our previous research, we still believe that we still have more things to research in this area. So, what next? We plan to continue researching other different license managers because it looks like for us a great and interesting topic for research, as well as the other common and cross-platform multi-vendor solutions and technologies. Because it turns out that there are many types of the technologies that are being used by multiple vendors, and those technologies can be a very bad thing for those vendors. And we plan to publish a bigger research paper in the Q1 or Q2 of the next year. As the conclusion, we would like to have a short message that, so if you're a vendor, you just cannot trust anyone. So it might sound really obvious, but not so many vendors are listening to it. So if you are including the third-party code in your system, it might be bad. You should do the code checking every time. You should do the vulnerability research. You should always implement all the security features and mechanisms having by default by many compilers. You need to have the red team or internal vulnerability research team who is practicing a lot in fuzzing technologies. Because if you invest time and money into the fuzzing, it will remove most of the binary vulnerabilities on the first or second or the third run. And we also advise you to do the third-party vulnerability research. So basically, it's like hiring the third-party company, because basically they receiving their money for finding the bugs. And again, trust no one. So it might be obvious, but you need to always keep in mind. If you are business-to-business customer, so there are several obvious recommendations. We don't even want to touch them, so like implementing defense in depth strategies and everything, all those kind of things. And if you're a researcher, we want you to do the only responsible disclosure. So if you have identified the vulnerability, report it directly to the vendor. Wait for the until the vendor is fixed, and you can publish like the research white paper and everything. And it's really good to study common technologies and multi-vendor technologies, because if you're a penetration tester, it helps you a lot during the project. So let's say you have like a Windows operation system with all the installed features and everything, but you have that tiny little license manager that is not being studied by researchers, and you have like that huge security thing that helps you to get into the system and everything. So studying the third-party code is very interesting and challenging, and helps you a lot in the penetration testing. So thank you really for your attention.